we're still getting people coming in, but we'd better make a start, particularly as it's rather late for David. As I gather, he's still in Switzerland, looking after grandchildren when I last heard him talking, as well as looking after the health of the world. I'm not going to say very much, except because you've seen some details about him already. Just wanted to say that when we originally met up, he was clearly an expert on public health, but he was also clearly in those scenarios very highly respected. And he had a very perceptive comments to make, not only about public health, but also about academic medicine and medical careers in general. So it's really a privilege to have him with us tonight. There will be a recording, and David has kindly agreed that he wants to focus on answering questions, of which we have quite a number prepared for him already. And he's just going to give a brief introduction, and then we're going to go through some of the questions that you've raised. So David, I hand over to you.
Well, thanks very much, David. And, I come to this evening having had the privilege, really, of being the chairman of the WHO advisory group to the Emergencies program. And we've actually met 58 times for 2 hours a session since last January, mainly advising the Emergencies program on the COVID-19 pandemic. So during that period of time, I've been able to see a lot of different country responses and talk with people from around the world. And David, I'd just like to assure the audience tonight that despite the geopolitical tensions that are occurring at the top of the WHO and other organizations, the technical arm of WHO is working very, very well. And it's because of that, bringing together people from around the world. A good example is today, when there were 1,800 people on a Zoom conference about the new variant in the UK and in South Africa, laying out a research agenda for that virus. So the technical arm of WHO continues to function as it always has very well in helping get answers to very important questions and advising countries in policy options. And in addition, this job has also permitted me to just get to know WHO a little bit better, although I did work with them for many years in the past. So just a brief introduction on that, David, and to say that today's meeting was actually very interesting because it talked about the variants, presentations both from the United Kingdom and from South Africa and from countries around the world, talking about what they had discovered about this variant and how they see these two different variants acting. And what's very good news, I think, is news both from today's meeting and news from a meeting last week with BioNTech and the WHO advisory group on vaccinations, which I attended as well. And at that meeting, BioNTech indicated that they had tested their vaccine in animal models infected with the UK variant, and that the vaccines had prevented infection or had prevented serious illness in those animal models. So the vaccine appears to be hardy, and that's information that's also coming from the United Kingdom in looking at antibodies from natural history, natural disease, and also from those who are vaccinated with the mRNA vaccine. And those sera do neutralize the virus in the laboratories at Public Health England. So I think we're pretty certain, David, that the vaccine in the UK is covering the strain in the UK. The South Africa variant's a little different, and they're right now testing that variant based on sera that they have from natural infections and from sera they have from some vaccine trials, and they don't yet have full answers on those studies. So that's sort of an update on vaccines, David. Maybe there are more questions.
Well, there are several questions about it. What about children? Is there any evidence about vaccine efficacy in children?
There's been very little study on vaccine in children. And it's a very difficult study to do because the endpoint has been serious illness for these studies. And children, we know, don't get seriously ill in the majority of cases. So the studies would be very difficult to conduct among children if you're looking for an endpoint of serious illness. And in fact, as I think most people understand, it's not yet known whether the mRNA virus is only modifying infection so that there's less serious illness, which was the endpoint, serious illness, or whether it actually also prevents infection and prevents nasal carriage of the virus, and therefore can be used also to decrease transmission. That will be understood as time goes on. Studies are going on, but at present we know that it will prevent serious illness.
So in that case, children will be offered the vaccine in due course when they get down to that age. And how early do you think, how low down would one go, to what age?
I expect what will happen is governments will try to protect their hospitals and save lives. And once they've done that with their vaccination strategies of getting those with comorbidities, the obese, and possibly and also the elderly and those in care homes, once they've decreased mortality, they may then decide that they want to change their vaccination strategies. They'll be vaccinating health workers, but then the idea will be, what do we vaccinate next? And that will clearly depend on what the vaccine does. If it decreases transmission, and it's understood that transmission is occurring in schools, then they will probably target schools. If it's occurring in people who are going to pubs or going out and socializing, then they may target those populations. But for the start, it will be a vaccine used to decrease mortality, to prevent serious illness in people who are exposed to the virus, including health workers who are exposed sometimes to very high doses.
I mean, is it possible to comment about the different types of vaccines? Are they equally effective? And what about the Chinese and the Russians and so on? I mean, there's a kind of 150 different vaccines in the pipeline. I mean, where are we going to go to? Where are we going to stop?
Yeah, it's a very good question. And as you know, there's been a lot of discussion about whether the vaccine trials have been long enough and valid with the regulatory agencies. I think that everybody can be fairly sure that the mRNA vaccines have been studied, have shown what side effects to expect in the short term, and now post-vaccination surveillance is very important to determine whether there are any rare side events that are occurring. So that will keep on, and the mRNA vaccines, we understand quite well, very effective at preventing serious illness. In fact, 90 to 95% effective. The AstraZeneca vaccine, as you know, there was some difficulties in understanding the data, and it has now been licensed in the UK with an efficacy thought to be around 72% in preventing serious illness. In addition, there are some studies that suggest that this vaccine may be having an impact on nasal carriage of the virus as well, and that would be welcome if that is the case. So the AstraZeneca vaccine is licensed in the UK. The US is continuing its trials, as are other countries, and it's felt that they may not license until they get the results of the studies, which could be as early as February or as late as February, whichever way you want to look at it. Then there's the inactivated Chinese vaccine, which has been licensed in China, which is being widely used in the Middle East. WHO has not yet seen the licensing dossiers and the criteria for that, so they've not made a judgment on that vaccine. They will not pre-qualify that vaccine until they see all of the information. Pre-qualification by WHO means that that vaccine is then assured of being prepared safely and is consistent in its titer and can be used effectively and can be purchased then by UNICEF and the other procurement agencies in the international organizations. Then there are other vaccines which are also being studied. There's the Russian vaccine, which is an adenovirus vectored vaccine, very much like the Oxford vaccine. The Oxford vaccine, however, is a chimera. It's a mixture of a chimpanzee adenovirus and the coronavirus. Whereas in Russia, it's a mixture of a human adenovirus in fact, two different humanoadenoviruses and the coronavirus. The advantage to the vaccine in Russia may be that it's two different adenovirus vectors, because remember, antibody is prepared both to the vector and to the virus that's hooked onto that vector. So by using two different vaccines, one for the second dose, they may in fact have a vaccine which causes even stronger immunity than the AstraZeneca. But the AstraZeneca, as I say, has been licensed, had no chimpanzee virus, and 2 doses have shown to be effective in preventing serious illness. Then there are virus-like particle vaccines as well, and those vaccines are being studied. They're still in early study. And there are a few other types of vaccine that are being studied as well, but those are the major ones. And so far, WHO has looked at the mRNA vaccines and the AstraZeneca vaccine, and we'll soon be looking at the Russian vaccine, because the Russians have now shared their licensing dossiers with WHO.
I mean, there are several questions automatically come up about that. For example, immunosuppressed people, the question has been posed in the form of Pfizer and AstraZeneca. Are they both effective in immunosuppressed? Should they be given to immunosuppressed, and so on?
Yeah, and that's a good question. And again, the answers aren't all there. And it will take several months now to understand, by using the vaccine in a broad population, including elderly people who may have a decreased immune response and other immunosuppressed persons, whether or not that vaccine is effective. Hopefully it will be effective, but again, it's not known. Very interesting in vaccines. Some vaccines are effective in persons HIV infected, others are dangerous to use in those people. It just depends on what we see as we move forward.
I mean, there's a question about that, which is the question about natural immunity. How does natural immunity compare to vaccine-induced immunity? Is there a comparator that one can actually use and say?
Yeah, as far as I know, that's not been sorted out yet. But clearly, there is a excuse me, there is a cellular immunity, which is very important, which is created at the time of the infection. And that innate immune system certainly does respond. And as of yet, the real correlates of protection are not understood. But it's known that antibody does neutralize living virus in the laboratory through neutralizing analyses.
Right. But the question then becomes, when you're vaccinated or you're immune, how does your behavior change? What do you do? Can you behave freely, wander around, do everything you used to do?
I think you know the answer to that, David. And until we know what the vaccine is doing as far as the virus that's carried by people, we can't change our behavior. We have to protect ourselves and protect others through the
right.
usual.
So behaving freely is not on the cards for quite a while. Now, what about the Johnson & Johnson? You haven't mentioned that one. Is that one any different from the ones?
Yeah, I'm not familiar with the Johnson & Johnson vaccine.
Sorry?
I can't talk about it because I don't know much about it.
We don't know about it. Right. The beginning of the obvious questions for the UK. If you were working at the coalface, would you be happy with having one Pfizer vaccine and go back to working in a situation where you've got aerosol generating products?
I would be careful no matter what. I would have the vaccine, but I would also be careful. And that's not just because of COVID, that's because in general, infection prevention and control is extremely important in hospital settings. And aerosol procedures generate aerosols, which can infect with COVID or with other pathogens as well. So there's no excuse for a lack of infection prevention and control measures in hospital practices, including pulmonary therapy.
Right. And there is the question about the British delay. That's the other thing. What do you feel about the British delay in giving the second dose? Is that an acceptable protocol?
Well, nobody can answer for sure whether it's acceptable. What the company said last week, the BioNTech company said, is that they recommend a second dose because the first dose at about day 12 shows the effect of the vaccine, the protective effect. But if you give a booster or the second dose within the 6-week period, 4 to 6 weeks, you will then see an increase in antibody response, and that will remain fixed for a longer period of time at a higher level. So they recommend no longer than 42 days or 6 weeks. And where did that come from? That came from the fact that during the studies, the maximum persons who were vaccinated were at 42 days after the first dose. So they didn't go further in their study, and they don't make any recommendations. And so WHO has made those recommendations as well.
Right. The issue that then arises, if you've had both doses, can you still catch COVID? Are there documented cases where people have actually got PCR positive status post both doses of vaccine as yet?
Well, as of yet, there's no evidence of that. But remember, it's not known how long immunity might last after vaccination and what that immunity really is. Is it an immunity that's modifying infection, or is it an immunity that's protecting against infection? So much to be learned during the next year, but governments in general around the world will be happy if the vaccine does what it's said to do, and that is decrease mortality and decrease the burden on hospitals and healthcare systems.
I'm obviously resisting the temptation to put in the question as to anybody looking at the T-cell response in sufficient detail to beginning to get meaningful results.
There are lots of studies going on, including in the UK, and those results will come out eventually, but I haven't seen many published results on them.
You haven't seen.
No, but I'm not an immunologist either. I'm a epidemiologist.
Right. No, because I just thought we should make that point clear. It means that I can quote you whenever necessary.
What you can do also is ask in your audience if there are immunologists who are doing those studies. It would be interesting to see.
But there is the person. Doctors asks, you said you're going to be doing some vaccinating when you come back, and somebody's raised the question: if he's 76, his wife is 73, he's had the first dose, should he volunteer to go and do vaccination?
Well, I certainly think it's a good idea to do that, yes. But again, wearing protective gear so that you don't become infected. And that includes, in this instance, the eyes, covering the eyes, and so that you don't infect others should you be carrying the virus, even though you have a certain level of immunity to protect serious illness.
Now, that's an interesting question about the eyes. The covering of the eyes is sometimes advocated, sometimes people go for masks only, not eyes. Is there any evidence for or against around that issue?
The areas where droplets can penetrate the human body are the eyes, nose, and mouth. So when there's direct face-to-face contact or contact with an aerosol, those are the 3 entry points. In order to protect others, we wear a mask. In order to protect ourselves, we physically distance. But health workers are different. Health workers must protect others and also protect themselves in close proximity to others. And therefore, they must wear a mask over a shield over their eyes to protect themselves from getting infected and then inadvertently transferring that infection when they take their masks off. So health workers are in a different category than the general population. And they wear masks and face protection, eye protection for different purpose than do the general population.
I mean, is there any projection from WHO about whether from your past experience, it would be relevant, going to be like flu, there's going to be an annual, or possibly is there going to be a combined flu and COVID campaign? in the same or in different vaccines? I mean, theoretically, with the RNA, you could have two.
Yeah, I think these are all things that innovators will be working on in the future. At present, we need to understand things and they need to set up the basics, such as a network where there's free sharing of data, specimens, and also sera from people who've been infected. And this should be a global repository so that the world can have access to these as they move ahead. Once those types of systems are set up, keeping an eye on what's happening with the virus as far as its genetic sequence, then there will be ways that we can be sure that if there is a need to alter vaccines from time to time, there's a mechanism in place to do that. And that mechanism will also be trying to determine whether or not disease is less or more severe caused by variants and more or less transmissible, again, caused by variants. So lots to be understood in the world today, but I can't predict what will happen in the future. I can say only that this virus appears to be becoming endemic, like four other human coronaviruses, and we're going to have to learn to live with it. And once the population has had exposure to it, it may be that it becomes less virulent in those populations because they have some type of immunity already. And then we might want to target young children who are the new cohort without any immunity. You know, there are many different ways that this could play out. And that's why research and monitoring systems are so important, and a free exchange of information from those systems.
Yeah, because there are a number of questions. I mean, does the come up already again? Does the extension of the time between the first and second dosage increase the chance of viral resistance? Is there any evidence along those lines? And the other thing is, with regard to, you know, the reports that there are nasal sprays being produced in Israel as a vaccination strategy. How is that considered? Alternative vaccination strategies other than by injection?
Well, I think alternative vaccination strategies would be very important to be developing. As you know, there is a flu vaccine also that is a nasal spray
Yes.
vaccine. And those are technologies of the future. And when you look at influenza vaccine, it's a really archaic procedure of producing virus in egg embryo and then harvesting that and putting it into a vaccine. There are new virus vaccine platforms now, as you said, David, the mRNA platforms, and maybe they will be useful for vaccines in the future, hopefully, including the influenza. And of course, the holy grail for the influenza would be a vaccine that protects against the 17 known avian influenza viruses. And that would be a real accomplishment if that could be done in a period of time. So, you know, the other question about 12 weeks as opposed to 6 weeks, there's no data. This is the first time this will be done. So what's important is what the UK will be doing is monitoring what's going on and making a decision based on the evidence as to whether or not this was a sound strategy. I know other countries are considering the same strategy, get people vaccinated with one dose, because one dose after 12 days appears to offer its protective effect. And then booster or give the second dose to get those antibodies up in a way that they remain long-term or longer term.
I mean, when you say that people are doing it, the people are doing it as individual countries. So in the UK, it would be the MHRA that would be regulating that, whereas, or would be looking at the information from that. Is there any kind of international attempt to look at that? Is WHO requesting data on that, or perhaps commissioning data from particular countries to do it?
Yes, WHO has access to all of the data, and the regulatory agencies share that with WHO. And that's why at the meeting called SAGE, which is the WHO's advisory group on vaccines, the meeting last week with BioNTech reviewed all the evidence that's available on the BioNTech mRNA vaccine, and that vaccine was then put into a framework of advice to countries. The next one to be examined is the Moderna vaccine, and then the AstraZeneca vaccine in order. And then finally, the Chinese vaccine will be examined, and possibly the Russian.
there appear to be kind of bottlenecks in how these vaccines supply and where the vaccine is getting to people both in the UK and in Europe. That appears to be a recurrent theme that every country is putting up with. What do you think of these bottlenecks? I mean,
Yeah, well, clearly the first thing is that the industrialized countries have bought up all the supplies of vaccine that they can in advance, and they bought enough vaccines for their populations. What's important, though, is that other countries have access to vaccines as well. And that's why the COVAX facility, which is part of what's called the ACT Accelerator, which is developed within the UK with the European Commission, European Union, and other groups, that is a very important area which is striving to get vaccines, therapeutics, and diagnostics in a market that can be used by developing countries or lower income countries. And countries have contributed to the COVAX facility. Last I was aware was about 2.5 billion US, 2.5 billion euros to that facility in order that the facility can begin to compete in the marketplace to get vaccine that it can be made then available to lower and middle income countries, either purchasing it through grants from the World Bank or loans from the World Bank or in some other manner so that that fund can be replenished. So it's very important that this vaccine nationalism, which we're seeing now, is converted at some point into more equitable distribution of vaccines to all countries that need it. And that's every country in the world that requires vaccines.
I mean, would you say at present, where would you say with your previous experience with pandemics, where are we? Are we towards the end of the pandemic with the vaccination and the virus is becoming endemic? And how, if not, how soon are we going to reach that stage of?
Well, I think what we're seeing now is continued increases in transmission. Once transmission becomes at a more steady state, which can happen if there aren't people who are getting seriously ill, once the disease becomes more steady at a steady state, then I believe people will concentrate more on its endemicity and how to deal with it. If you remember, David, this is what happened with HIV. HIV emerged probably in the early 20th century. It then amplified in transmission in the late 70s, and in the 80s, it spread throughout the world, and it was being called a pandemic. But then as transmission stabilized, it was predicted as to where transmission would be occurring. It became endemic, and it's now an endemic infectious disease, which is treatable, fortunately.
I mean, that raises an interesting question, is the analogies are often drawn between flu and COVID-19 and between those kinds of, that kind of pandemic, but really it's not really a valid analogy in that case.
No, in fact, early on, it was thought that this virus would behave like the influenza virus. And so much of the modeling was done based on that understanding. Early on, the Japanese, I believe, were the first country to demonstrate that this didn't transmit directly into communities. It stopped off in clusters, and it was causing clusters that could be investigated, and you could actually find a source of infection and shut that source down. In fact, the Japanese found early on that it was nightclubs that were the transmission centers, and they shut them down rather than a blunt shutdown of their society, and were able to decrease transmission and prevent hospitalizations. So, it's very important to understand that this isn't influenza. And in the UK, in areas where it's just arriving or just starting to transmit, there still is probably a possibility to contain outbreaks and prevent large-scale community transmission. And of course, as the population develops immunity, there will be a modification in how this virus acts in humans.
Right. I mean, there are therefore technical issues that arise out of that. I mean, they're technical and ethical issues. The technical issue is that you've got one vaccine that is only allowed to move 5 times, or and in -70 conditions, and you've got another vaccine that is allegedly can be just kept in a normal refrigerator. I mean, what are is it correct that this Pfizer vaccine is only going to be available under the circumstances that are described? Is there going to be changes in that? And conversely, is there going to be a waning of the efficacy of the ones that are in the ordinary refrigeration?
BioNTech last week told WHO, this meeting of the SAGE group, that they are actually trying to lyophilize their vaccine. And if they're able to lyophilize it, that of course would make it a stable vaccine. The problem is the stability of the mRNA. And if they can lyophilize it in a way that it can be reconstituted and remain stable, they will then have overcome this problem of keeping it at -70. But remember, the Ebola virus vaccine is also a -70-degree storage requirement. And that vaccine has been successfully used throughout Africa in Ebola outbreaks because there are containers adapted for carrying it into the field and into communities.
Right. Sorry, I was just being notified about an immunization having taken place in America for 94-year-olds. So that was the telephone. I apologize.
Okay. David, also we need to be thinking about therapeutics, which are also a way that disease will be modified over time. And the work with monoclonal antibodies, the work with convalescent plasma is also very important because given early, this may in fact modify infection as well and be a passive immunization, if you would. I think you remember when hepatitis A was prevented by gamma globulin. And many people remember that. And today, rabies given early, rabies anti-sera protects people against rabies. And vaccine is begun at the same time, but there are ways that we can deal with this disease without just having a vaccine. And so antivirals, other therapies, as well as antibody treatments will be very important moving forward.
I mean, is there any particular model of therapeutics that is actually as innovative in a sense as the mRNA one? Because that's a major innovation to actually have succeeded.
Yeah, I don't think there are innovations as such in the field of therapy today, but there's a lot of innovative research going on, understanding the genomic sequence, understanding the targets. And so research has really taken a leap forward during this pandemic by so much investment going into therapeutics, diagnostics, and in addition, vaccines.
I mean, there's a very interesting dynamic, isn't there? Why there's no vaccine against HIV, whereas there's a vaccine, whereas this vaccine, and equally as the SARS, and indeed and MERS, and to a certain extent Ebola, there's no vaccine that's been produced that's been equivalent to these.
That's right. There was a lot of SARS vaccine research going on during the outbreaks back in 2003, but that dried up afterwards because the money dried up. CEPI, based in the UK, has actually been working on MERS coronavirus vaccines, but there's really at present no need for those vaccines because MERS coronavirus is transmitted from camels to humans on a regular basis, but then humans usually don't transmit person to person unless they're in a hospital setting, they're immunosuppressed people, or where infection prevention and control amplifies transmission, as in Korea, where there was an outbreak from one imported case of about 200 persons and over 30 people died for that MERS outbreak. So there's no need for a human vaccine at present for MERS coronavirus, but there certainly is for camels. And if camels were vaccinated against MERS coronavirus, there wouldn't be this reservoir infecting humans on a regular basis.
There's another vaccine question which has actually come up, which is what do you think about the malaria vaccine program? Has the malaria vaccine program begun to have an impact on disease worldwide, or is it still?
Well, it's still under trial to see whether or not it does have an impact and what impact it has. But at 42% efficacy, it will be just one of many tools that's used in the fight against malaria. And what's very sound strategy for malaria is rapid diagnosis and treatment with a combination artesunate and another antimalarial.
What do you think of the antimalarial that was suggested for this? ivermectin. Was
Well,
that?
I think that it was a premature announcement, and the evidence showed that it was not effective.
Right. Yeah, I think that there are other questions that people want to put to you other than about vaccines. And I think we've covered a lot of vaccine ground, but one of the questions is about the origin of the virus. Is the
Well,
Chinese government cooperating? Are they not cooperating? And do you think we're ever going to know the solution to that question? There's a lot
well,
of urban mythology.
yeah, it's very difficult to identify the source of any new and emerging infection. It's still not understood clearly how Ebola, for example, transmits to humans. It's understood that bats can be infected in the laboratory and can be healthy carriers of the virus and not become ill. That's understood because that work has been done. There's also been PCR fragments of Ebola virus found in bat guano in Gabon and in other places where there's research going on. But there's never been an Ebola virus isolated from an animal in nature. So although the hypothesis and the probability is that it's the fruit bat, there's not any evidence of that. But from the first outbreak in 1976, of which I was a member of the team from the CDC investigating that outbreak, it was clear that in the Ebola outbreak in Sudan, which was occurring at the same time as in DRC, bats were playing some kind of a role because the outbreak occurred in a sugar factory and the sugar factory was full of bats and they were hanging from the ceiling every night and during the day. And so, it's just a question of being able to identify where that virus is in nature. Human monkeypox is known to be carried by some type of rodent, but that rodent has never been identified. There's never been an isolation of a virus from an animal in nature. So it's very unlikely that there will be a source of exact understanding of how this virus emerged into human populations. And I don't think that's what the team is there to do. The team, which includes someone from the UK, as you know, John Watson, who's with PHE, the team is going out there. They will be out there Thursday, and they will be talking about the research that's necessary to better understand where this virus might have originated, but they certainly will not be able to prove with any certainty how it emerged into human populations, although it will be clear where transmission hot areas have been, I would suspect.
I mean, there are other questions about community control that people have wanted to know the answer to. The discussion between more focused, targeted areas of containment versus the national containment, which do you think that they've had different impacts, the same impacts when you contain the population, isolating one population rather than another population?
Well, David, I think that in your audience, probably people would understand that the best public health is done at the community level and at the local level, because that's where there's trust in such things as contact tracing. Contact tracing goes on regularly for tuberculosis, for sexually transmitted infections, for HIV. People at the local level have the trust of the people who live there, and they know how to do these things. So it's always been a fact in public health that the public health response must involve the people and the people must be engaged. And I've always said in interviews on the pandemic today that countries that have their populations engaged and understanding how they can contribute to controlling the pandemic are the countries that are succeeding much better than other countries. And countries in Asia where governments have allowed local areas to do the response, have motivated people to wear masks, not made it a partisan issue as happened in the US, where masks are worn because people understand why they're wearing them. They've had good success. So engagement at the local level can't replace the response, but it can facilitate a central response if the center is setting up the correct policies and the implementation is done at the local area. Lots of experimentation going on right now with digital technologies to see if they're of any use in contact tracing or in notification. And they certainly have some application, not yet shown exactly what the impact is, but they will be something for the future. And we're learning a lot, just as we are about vaccines, from their use in the current pandemic.
I mean, there are all sorts of strange regulations. People have noticed the fact that the British government feel that sitting on benches is not such a brilliant idea. Those people have spoken about washing all items that come into your house and those kinds of regulations. Are those regulations really having a major impact on disease spread?
Well, early on there was concern that the droplets created by coughing, sneezing, speaking, or even singing would deposit on a surface. And if you touched that surface and then touched your face, you could become infected. That was a great concern at the start of the outbreak. And so precautionary measures were made about washing hands. And they're good measures to use anyway, because they prevent all types of respiratory infections. So there were precautionary recommendations made about surfaces because laboratory studies had shown that the virus could survive as long as that droplet remained moist for a period of time. And so surfaces were highly suspect. Today, if you ask WHO, they'll say that in their understanding, surfaces play a very insignificant, if any, role in transmission. Transmission is understood to be by people either asymptomatic, meaning 1 or 2 days before they develop signs and symptoms, or during those 7 days after signs and symptoms have been developed. That's when transmission is felt to be greatest.
Thank you. Is there any evidence, further evidence about the question of anaphylaxis and anaphylactic responses to any of the vaccines?
Yeah, well, it seems that there are some serious allergic reactions to the BioNTech vaccine, and that's due to the lipid coating of the messenger RNA, and certain people are sensitive to that coating. So yes, when vaccinations are done, there must be a period of observation afterwards and the equipment necessary to prevent or to treat should there be an allergic reaction or an anaphylaxis.
This hasn't occurred with vaccines that don't have the lipid coating. It's only occurred with the
As far
Pfizer.
as far as is understood, it's not concerned with the AstraZeneca vaccine.
Right.
But any hypersensitivity could be developed to many different components of a vaccine, not necessarily, and that would not necessarily be known at the start, nor possibly show up in clinical trials. It would have to depend on post-vaccination surveillance to determine that for sure.
I know we're drifting back to vaccines again, but with the Pfizer vaccine, is there any evidence of antibody against the chimp adenovirus?
Not in the Pfizer, no, but in the
in the AstraZeneca.
In the AstraZeneca, I think it's hypothesized that there will be antibody. I don't know whether it's been actually sought within the studies or not. The studies were concentrating on serious illness as an endpoint.
Right. Then there are other questions relating to what are you and the WHO doing about provision and planning for the next pandemic? What are the lessons that have been learned this time around for the next one?
Nothing can replace good public health and lessons learned. And the lessons that were learned for SARS and MERS coronavirus in Asia served them quite well, because by the 23rd of January, most countries in Asia, and I'm talking about Singapore, Hong Kong, South Korea, Japan, were identifying people who were coming in from China with infection and were already responding to the outbreaks. They had heard the WHO on the 5th of January talk about a cluster of respiratory infections in China. Then they saw the sequence that came out a few days later, and they were on the alert and ready. Countries in Europe and in North America appear to have had the virus enter about the same time, or possibly earlier, and they did not respond in the same way that Asian countries did. Germany responded when they first understood that they had an outbreak in quite a masterful way. and was able to continue contact tracing throughout the first surge and has continued to do that right along, although they've now put in some other mitigation measures, such as shutting down certain parts of the economy as well. So countries that learned lessons and applied those lessons, were on the alert early and responded earlier, are the countries that seem to have had a more sustained and response and lower mortality and lower burden on hospitals.
So in other words, the early alertness is the lesson for the future.
That's one lesson. The second lesson is to understand where transmission is occurring and shut that down rapidly. Don't use a blunt tool to shut down the whole economy. Shut down where transmission is occurring. And that takes a lot of investigation. And then it takes courage to shut those areas down against the lobbies that will be developing to not shut them down. But when they're shut down, then they should be compensated, and you can compensate targeted rather than an overall economy. So lots of lessons are being learned. And, I think that once all the lessons are put together, there will be probably a new approach to response to pandemics. But the most important thing is good basic field epidemiology and public health.
That raises the issue as to whether Britain has it right in its provision of good epidemiology and public health. And do you think we should be doing more?
Britain has been a leader in public health. Britain is the country that developed public health activities through its military service in the colonies. Britain has always been at the forefront of public health and still is at the forefront of public health. The difficulty has been in the UK and in many other countries, including the US, that there's very difficult dialogue at times between the political leaders and the public health leaders. And what I learned very early on in my career at CDC in Atlanta was that every outbreak needs a trusted face, and a face that can be constantly communicating clear messages, not contradictory messages, but clear messages. And in countries where that's occurring, I believe the response has been smoother than in countries where political leaders sometimes give one response and the public health leaders another response.
We've got questions that arise about staffing levels as well. That it isn't only doctors' staffing levels, but physiotherapists for the pulmonary impact. Are we producing internationally the right proportion of the other healthcare workers that have played an important role in the pandemic?
There's a shortage of health workers in almost every country. And what needs to happen is some task shifting needs to go on so that lower levels of health worker can do some of the more important tasks that they're doing now. And David, you told me that you have a family member who's volunteered to do vaccinations, who's not medical at all. And I think that's also very important, to train up a cadre of people who can take these responsibilities when there is an outbreak. Germany has over 1,500 contact tracers who are lay people from the community or students who have been doing their contact tracing. To train up a group of people like that in advance is indispensable. And that will hopefully be one of the lessons from this pandemic.
I've already said so. Because it's an interesting question about, of course, it raises the interesting question about visa structures in Britain and what is the impact of Brexit on both supplies and stuff.
Nobody wants to answer those questions, and I certainly don't want to.
That's far too complicated. But the one of the kind of big questions is coping with unpredictability. Are the population in the countries that you've mentioned done well? Is it because they cope better with unpredictability, and that we don't cope as well with the unpredictability and the uncertainty of the current situation?
Well, I don't know. I think nobody really copes well with uncertainty. But if people feel that they're playing their own role in preventing the outbreak from continuing to spread, they can then at least have a little bit of destiny in their own hands, as well as understanding how to do their own risk assessment. People need to be doing that. There were all kinds of concerns about people traveling during the holiday season, mixing with family members. The answer to that is as follows. Do your own risk assessment. If you've been in an area where transmission could have occurred, and you'll know that because you were at an office party, or you were in a pub, or you were in an area where people weren't wearing masks, then you should think twice about going into a household where there are elderly people who might be infected. Empower people to make those decisions. The government doesn't always have to make those decisions, but it's a slow process for people to understand that. And the government is playing a role now in forcing physical distancing. But once that's finished, people need to be doing that as well. When the UK came out of lockdown in July, people just went back to life as normal again. And that was the wrong way to go. It should have been people remained cautious, and those places where transmission is known to concern remained closed down. But that didn't happen in most of European countries. People were so relieved, they just threw it to the wind and went out and began to behave as they had before and increased the transmission during that period.
I mean, coming back to finally to the question of children, as you said, you know, kind of looking after grandchildren. What is the issue? What is the issue with the schools? Is the schools therefore sit slightly outside what you're saying about risk assessment, that they should be given a privileged status, or should they be handled more stringently than others?
Well, a risk assessment takes into consideration many things, not just SARS coronavirus 2. And that risk assessment for schools includes the needs of children in their formative years to be in a social environment, as well as the needs to prevent against infection. And so there has to be a risk assessment, a balanced risk assessment. It's understood that children do not become infected to the same extent as do adults, although the variant in the UK may be showing a greater affinity for some children, but it's not yet known. But at present, we understand that younger children don't become infected and aren't a threat to the household. That's come from studies in Asia, in many parts of the world, including in the UK. So the risk assessment there is, what is the risk of these children being a foci for transmission as opposed to an interference in their development? And I don't know that that risk assessment is completed yet, and it maybe will never be completed until after the outbreak's over. And some of the effects of the lockdown and the closure of schools are known. But you know, the risk assessment is not just around the risk of getting infected, it's around the risk of many other things. And I would just say that strategies of governments are not risk assessment. What strategies of government are to prevent death and prevent hospitals from becoming overwhelmed. And if that occurs from the current vaccine use, then we'll see a change in what government policies are. And hopefully those policies will rectify any of the mistakes that they might have made moving forward. Remember, everybody's building the ship at the same time.
Right. I mean, I think that I think what you've done tonight is, I think you've provided, I hope, this audience with the reassurance that we're in safer hands than sometimes we think when we read the media, because I hope you've inspired that kind of confidence in people around about here, that their questions are answered, and also that there are unknowns which can't be answered, but which people are trying to find the answers to them.
Yeah, David,
So,
I would just
thank
say,
you.
yeah, I would just say I chaired a research panel in the UK providing research funding for studies that could be completed within 12 months through the UKRI. And that was quite an interesting experience for me to see the amount of money that the UK is making available for research, and also the very important research activities that are going on. And I think the UK is a leader in producing results during this pandemic and will remain a scientific leader in the world, no matter what the future holds.
Thank you very much. Many thanks. And we look forward to you being back here as well.
Thanks very much, David. It's been a pleasure to speak with you.